Hey, welcome back to the third casual series of Leetcode. For today, we're doing shuffle strings, and we're given a string s and an integer arrays of indices of the same length. So this is how they look like. S is a string, and this array over here is containing the index that corresponds to each of the characters over here. And we have to shuffle S such that the character at the ith position move to indices in the shuffled string. That's a lot of words, but what this means is we will put the character that has the 0th index first. So in this case, this 0 corresponds with L. So L will be printed first. So if you arrange them accordingly with respect to the indexes, then you will get out Leetcode. So to make it clearer, I'll be tracing this out. So in this case, L is the first character, because that corresponds with index 0 over here. Then the next step will be to look out for the character that has index 1. So in this case is E over here, because that has index 1. So LE, we get LE. The next one is the character at index 2. So this is E2. So we get LEE. And we will look out for the character with index 3. This will give us LEET, leet. Then finally, we'll look out for the next index 4. That corresponds with C. So LEET C, 5 O, LEET C O. 6 corresponds to D, LEECOD. And finally, index 7. So that gives us LEETCODE. So hopefully this trace makes the question clear and what is the problem that we are going to solve. So the first example is pretty hard compared to the second one. The second one is just A, B, C. So in this case, it's really simple. So this just gives us A, B, C if we output the characters in the same order as their indexes in indices. So for this question, the length of S and indices would be the same, and they correspond to n. N ranges from 1 to 100. So what this means is S and indices would have a maximum length of 100. Very forgiving constraints. And S consists of only lowercase English letters. Really great. And indices would range from 0 to less than n. So if you have a length of 100, then the indices would range from 0 to 99. And all values of indices are unique, which makes sense because indices are supposed to be the indexes of each respective characters in S. So that's pretty much the question. So off the top of my head, I can think of two methods. The first way is to zip S and indices together so that you get a list of tuples. So let's say if S is equals to, let's say code leet. Let's reuse the example in example 1. Let's say S is equals to code leet and indices is equals to 456702113. If you zip these two together, if you call zip on S and indices, you'll get back a zip object. And this zip object, you can think of it as a lazy iterator. A lazy iterator is an iterator that can be iterated on. So you can call a for loop on it and it will give you back the results. And if you evaluate it, then if you fully evaluate it by calling list on this zip object, so let's say zip object, then this will give you back a list. And each of these lists will contain a tuple. So in this case, since S and indices, if you call length of S, this will give you 8. And if you call length of indices, this will give you back 8 as well, because of the constraints that we mentioned in the question earlier. These two lengths are the same. Calling zip on S and indices would give you back an iterator object. And if you call list on this iterator object, then this will give you back a list of tuples of string and integers. So this zip object over here will have 8 items. and each of these items is a tuple. So if we call zip of s an indices, then in this case, this will give you back a character. So let's say C. So give you back C followed by 4. O, 5. D, 6. E, 7. L, 0. E, 2. E, 1. And finally T, 3. So now that we have this list of tuples where each of these, where we get a representation like this, you might be thinking of the same thing. We can sort this list by the second item in the tuple. So this will give you, so let's call this list of zip object, let's say unsorted zip. Let's set this to be equal to this. And if we call sorted on this unsorted zip, and you specify a key function which this sorted function will use to pass this tuple. This X over here represents the tuple in each of these items in unsorted zip. So this function over here will be executed on every single tuple over here. So if you pass in, let's call this tuple, give it a better name. So if you pass in a tuple over here and you make it return back the second item in this tuple, lists or tuples are 0 indexed. To our viewers that are new to Python, this will give you back the second item in each tuple. So now what this means is that we will be using the second item in each tuple as the key to sort this list. So this will give you back the list using the second item as the sorting key. And if you do not specify, if you use the default function, the sorted function over here will give you back a copy of unsorted zip, and this will be sorted in ascending order. So what this means is, let's call this sorted zip. This is of type list of tuple of string of integer. Then this sorted zip will be equals to this same representation, but the zeros come first. So the first tuple would be L, because it contains index 0 followed by index 1, followed by the E at index 2, followed by T at index 3. Then we have C at index 4, O at index 5, D at index 6, and E at index 7. So by sorting the list of tuples by the second item in each tuple, you now have a nice representation of all strings in the correct indices. And now our job would just be to extract out just the string or the first item in each tuple and reform that into a string. So what we can do is, for tuple in sorted zip, you can then just define a final string. This final string would be containing the final answer, and we can just append this final string with the tuple at the first position, which represents the string in each tuple, and this will give you back a final string equals to Leetcode. So this is one approach. There are other approaches. That's one other approach I can think of, but let's go with this approach first. So now let's replicate that. So the first step would be to, let's call this zip as an indices. This would be a list of tuples of tuple of string and integer. Let's set this to be equals to zip, and let's pass in as an indices like this. So we can then fully evaluate it by calling list on it. When you try to cast a zip object into a list, this will fully evaluate the lazy iterator, giving you back the full list. So for lazy iterators, I guess I'll cover this in a separate video. But for now, please bear with me and just know that we are fully evaluating this lazy iterator into a list. So now this is unsorted, so let's call this sorted as an indices. So similarly, this will be a list of tuples of strings and integers, and this will be sorted like this. We will pass in the first parameter, which is the collection to be sorted, and the second parameter, this is not really a second parameter because we are passing the key by a named argument, but this key will take in a function. And to make life easier, I'm using a feature of the Python interpreter called lambda functions or nameless functions. So lambda, I will call this tuple. This function will be called on every single tuple in this list. So I'm just giving it actually maybe tuple is not a good name because that is a reserved input. You can see that the Python interpreter is giving us a different color. So if it gives you a different color, it's usually a bad idea, especially if you want that to be a variable. So let's call this input tuple. So we will make this function take in a tuple and return back the item in the tuple that you want to sort by. So in this case, the integer. So once we're done, now that we have sorted it, we can do for input tuple in sorted as an indices. Let's define a final string as well, which represents the final shuffled string that we return back to the user. We will append this with the input tuple at the 0th position. So the first item in this tuple over here. And we will finally return the final string like this. So that's pretty much it. So let's trace this out with this same test case. So actually we pretty much traced it already, but zip as an integer over here would be equals to this representation over here. Yeah, I guess it's a good thing that I wrote it out. I don't have to have the pain of writing this out by myself. But this sorted as an integer will be this representation over here. So I'm just going to put it on a different line so that you can see this better. But we are sorting this zip as an indices by the second item in the tuple, and we get back this representation. So now let's trace line 30. The first input tuple will be L0. Input tuple equals to this. Final string is now equals to an empty string. And if we append the first item, now final string will be equals to L. And we're done with the first iteration. Let's go to the next item in sorted as an indices. This will be equals to E1. So now we append E in the first position. So now final string is E. Now let's move on to E2. You get E. You get. Now let's move on to the fourth item, T. Now we have T. Now we have C4, C4, O5, append O in the first position as usual, D6. Now we append D here, and finally E7. And this gives us back Leetcode and return back Leetcode. Final string goes to Leetcode, and we're done. So this is a demonstration of tracing in the technical interview. So I hope this is a good demonstration of how you can use tracing to ensure that your algorithm has no bugs. So much for showing that this is input table. As you can see, tracing doesn't always eliminate you of errors. You can still get screwed if you're not careful, and I just got screwed right there. If this was a technical interview, I would probably be faulted for that. But okay, we managed to solve the answer faster than 24% of submissions. Not the best, but I guess it's decent. So the time complexity in this case, if you let S and indices to have the length of S indices to be equals to let's say n. In this case, this expression of zipping these two, zipping Zipping this will be O1 because this zip object is a lazy iterator. It gives you back an object of type zip, and it is not evaluated yet. Like, there's no iteration in this expression, so this is still O1. But by casting it into a list, that is going to fully evaluate the iterator, the lazy iterator. So calling this would be ON, because the Python interpreter will be forced to fully evaluate the zip object to get this. So this step on line 30 is ON. Sorted as and indices, in this case you are sorting this by this key. Sorting, unfortunately, is O n log n. As for why is O n log n, I will cover that in a separate video, but in this case, the sorted function over here, if I'm not mistaken, it uses a variant of merge sort called team sort. Correct me if I'm wrong, but uses team sort, and team sort has a times complexity of O n log n. So this will be O n log n. And we also go through one final iteration over here to get the first item from each tuple. So the for loop from 37 to let's just call this for loop. I'm changing the line number as I type. So, but the for loop in this case will be ON because we have to iterate through the sorted list to get the first item from each tuple. So that's ON as well. So in total, the time complexity is pretty expensive. If we really count all operations, it will be O2n plus n log n. But when it comes to getting the time complexity of an algorithm, we remove all coefficients and we leave the higher power here. So in this case, it's n plus n log n. N log n is the higher power, so it's a higher power, so it's O n log n. So yes, the time complexity is O n log n. For the space complexity in this case, we are making a copy of zip n and indices over here, a copy of s and indices, this zip over here, so this ON, and sorted s and indices, sorted also returns back another copy, so that's O2, another ON over here. And we have a final string, which is also a copy of s, so this is also ON. So we'll have 3 variables that's making copies here already, so that is O3n. Very expensive. But if you remove the coefficients, this gives you back ON. So this is the first approach. This will give you back a time complexity of ON log n and space complexity of ON. And this is using the first approach, which is using zip and sort, then extract first character from tuple. Okay, so this is strategy 1. Okay, I hope this was a clear explanation for the first strategy. Let's go through the second strategy. The second strategy would be to... Okay, let me just erase this. This is recorded, so this is fine. I'll leave it to you to look at this video. But the second strategy would be to similarly iterate through s and indices, and instead you can place you can create a dictionary where this dictionary contains, let's call this index to string, and this will be of type dictionary to integer to string, and this index will contain the index to the character that you have. So for example, if you have this same test case over here, then in this case, index 0 will be, the key of 0 will be mapped to L, 1 will be mapped to E, 2 will be mapped to E, 3 will be mapped to T, 4 will be mapped to C, 5 will be mapped to O, 6 will be mapped to D, and 7 will be mapped to E. And how you will create this dictionary is by doing a simple iteration by range and getting the corresponding character and indices from S and I. So let's show you how we do that. So for I in, let's initialize, you can ignore this, this is the final result, okay. Let's trace this out with an empty dictionary over here. Ignore the top, let's start off from here. And you can do a for iteration over here. And let's say for index in range length S, the first character from S would be equals to S at index. And let's see. And the corresponding character index will be equals to indices at index. So now that you have the character and the corresponding character index, you can set index to string at character index to be equals to character. And that's pretty much it. And once you're done, let me just trace this out so that it's clear. So now you have, so range of length S. Length S in this case will be equals to 8 because S has a length of 8. So this really evaluates to range of 8. So range of 8 for our viewers that are new to the range function over here, this will give you back a lazy iterator, a range object, and this will return back 0 to 7. So it's inclusive of, sorry, it's exclusive of 8 over here. So let's set this index to be equals to 0 first. And character at S index, will be equals to C, and the character index will be equals to indices at this. So in this case it's 4. So we are saying index to character string at 4 is equals to C. So now we have 4 and we have C. So I hope this is clear. Let's carry on with the rest of the inputs. So now index now goes to the next iteration. Index is now 1. Character is now O. Character index is now 5. And now we're setting 5 to E code, right? I think it's O. Yes, it's O. It's this character and 5 here. So 5 is equals to O. So let's put in 5, O. Let's continue. Index equals to 2. Character is equals to D. Index is equals to 6. So we're saying 6 is equals to D. So let's do 6 equals to D. Let's continue. Index equals to 3. Character equals to E. Character index is equals to 7. And index to string 7 is equals to E. So let's set this to E. Let's continue. Index 4. Index 4 in this case will be equals to L. So L. Character index will be equals to 0. And 0 will be equal to L. So now let's put 0 to L. Let's continue. Index 5. Index 5 is E over here. So E, character index will be equals to 2. So in this case 2 will be equals to E. So let's 2 equals to E. Let's continue. Index 6, the second last character, E. And the corresponding index is 1. So character index equals to 1, character equals to E. So this will be 1 to E. Let's populate the dictionary as usual. Pardon the syntax errors. And finally, oh my goodness, we had a final index T. And the character index is 3. So index to character is equals to 7 equals to t. So this gives you 4, 5, 6. Oh, sorry, character index E3 equals to, oh, sorry, I traced it incorrectly, did I? Yes, I think oh, sorry, T and 3. Yeah. Index 3T. So 3T, Leetcode. Yeah, sorry for the confusion right there, but you get the idea. And once you have this index to string, all we have to do is iterate this dictionary linearly by the orders of keys, and we will get it. So for index in range length of s again, we will just create a final string as usual, initialize to an empty string, and we'll just append the final string with index to string at this index. So as usual, this range will range from 0 to 7. So index is equals to 0, and final string is equals to plus equals actually, yeah, I'll just trace it here. Final string equals to empty string. In this case, index to string at 0 is equals to L. So you append final string with L. Next iteration, index 1. Index 1, you get E, so you get E. Index 2, you get E as usual. Index 3, you get T from the dictionary, so T. And index 4, C. Okay, index 5, you get O, so Leetcode. 6, D, and finally 7, index 7, E, giving us Leetcode. So this is also another strategy that you can do. I won't really call this a tracing. I won't really call this a simple algorithm breakdown since I'm coding it out. But fortunately, this question is simple enough to do that. So let's quickly implement this. So for now, we will define the dictionary index to string. This is of type dictionary integer and string. Let's initialize that to an empty dictionary, and let's iterate the index from range length s. So index in range length s. Let's get the corresponding character as index. Character index for this corresponding character that we are visiting. Let's call indices index. And let's populate index to string with this current character and character index combination. So to remind you again, the key in this case is the index and the value is the character. So after this iteration, we have fully populated index to string as we shown during the tracing just now. And let's iterate through this again. So this would be final string. We will proceed to get the index from 0 to 7 and get the corresponding character at this index like this. So this will get the character and we can return the final string. So let me just quickly check this again and trace it quickly mentally. We have already traced it earlier, so it should be great. Okay, indices, index to string. Okay, we populate the dictionary here and we iterate the index from 0 to 7 so that we get the corresponding character at each index from 0 to 7 in sequence. So we get the answer. Let's run this code. This passes. Let's submit this again. And wow, okay, this is I don't know. The Leetcode. I guess this is an easy question. So slight improvements in your algorithm doesn't really matter much because the size of the input is really very small. So to be frank, the first and the second method doesn't really have much difference like in production, or like if you run the script like just like that. So In this case, the time complexity, let's analyze the time complexity of this second approach. In this case, this will be O(n) because you are iterating through the length of S. So this is O1. Getting an item from a list is O1. So this is O1, this is O1, and this is O1 as well. So everything is O1. So this is pretty much O(n). Similarly over here, we do O(n) over here. And we are appending final string with index to string for each iteration. This is O1 as well. So O1. So actually this second approach is more efficient in terms of time complexity. So in this case, the time complexity is just O2n. But after removing the coefficients, you get O(n). So this is actually more efficient compared to the previous algorithm, which is O(n) log n. For the space complexity in this case, we keep a copy of all indexes to each character. So if your string is of length 8, then your dictionary will have 8 key value pairs, so it's O(n). And in this case, we don't really use we use some memory here for character and character index, but that's negligible. That's O1 for each variable, and these variables are being overwritten in each iteration. So space complexity is O1. Final string is a copy of S, so this is O(n) as well. If S is 100 characters, final string will be 100 characters as well. So in this case, space complexity is O2n. Same as our previous iteration, our previous implementation tool. So pretty good. So similarly, space complexity is O(n) here as well. Well, it's raining here. But okay, that's pretty much it for this demonstration. In summary, I would recommend the second approach over the first approach because it's more efficient. So that's pretty much it for this question. I hope that you enjoyed this. If you find this useful, please give us a like and subscribe, and we will see you in the next video.